I'm BNEWS reporter Theo Dewar, and I recently had the opportunity to attend the first LEGO League Eastern Massachusetts Championship, where the Marshall Simonds Middle School robotics team was proudly represented by the Space Potatoes. I met with some of the teammates. So, are you excited to be here today?
Yeah, very.
Yeah, it's really cool because you don't really experience this all the time.
Anything you're looking forward to today in the competition?
Probably the project because we've been working hard on it.
It's probably the award ceremonies to see what awards we might have won.
Everything.
Besides building, coding, and operating LEGO robots, the teams were charged with a research project.
Our project is based on finding a better way to farm in space.
We have successfully come up with a way to farm in space.
Our solution consists of automated pickers, water tubes, a large growth chamber, and centrifugal force in order to make the process of growing plants in space more natural and make it more efficient than NASA's.
We will use moisture sensors to tell when to grow the plants, to water the plants, and then we will use automated arms to pick the plants when they're done.
Some of the benefits of our idea is that the plants will grow faster because they have a sense of oxygen, which helps them grow.
Our growing method is different from NASA's because we plan to have a higher volume of plants and a greater variety of vegetables. Since plants produce oxygen as they grow, a higher volume of plants will make our system self-sufficient in oxygen and in food.
I took a walk around to see what some of the other schools in the competition were up to. Tell me about your projects.
Hi, we're Team RoboSheen, and this is our project about growing fresh vegetables in space, specifically bean sprouts. Now here's the device. It's our prototype so far. It's a small self-contained device, and within it is a small pouch of of seeds. This pouch is both translucent and breathable, and also is very lightweight, so you can carry as many as you need into space. So instead of astronauts only getting the fresh vegetables they need every few months, now they can eat them every day.
Very creative, thank you. Here I am with some more people and they're going to tell you about their project.
Our project is about manufacturing spare parts in space. And so we have a solution, a titanium 3D printer that can be used in microgravity situations.
So we've used a centripetal chamber, which is two spinning basically discs, and they contain the printer. And here, if you turn this on, it's spinning, and the titanium dust will be at the very edges, and it will simulate about 2 meters per second squared of gravity.
The current metal 3D printer is the Pro X DMP 320, and it's great. It's a great metal 3D printer, but it's way too big for NASA to send up. So if we eliminate the cooling system and just run water or liquid nitrogen, we can use nitrogen, which is already used in 80% of the atmosphere of the spacecraft.
I really like that idea. Thank you very much. At the end of the day, the Marshall Simonds Middle School Space Potatoes took home second place for gracious professionalism, as well as second place in the Alliance Robotic Lightning Round. From Newton North High School, I'm BNews reporter Theo Dewar. Back to you in the studio.